For the 12-4 notes, we're going to talk about the angle measures and the segment lengths. Now we're going to pretty much finish up any of the formulas remaining. So far we have got the arc when the angle's vertex is at the center of a circle, and then we did yesterday when the vertex is actually on the circle, but we're going to talk about when the vertex is outside of the circle and it crisscrosses inside the circle, but it's not in the at the center. So those are the two situations that we're going to look at in this set of notes. We've talked about what it means to be a tangent line when it just grazes one point of a circle. So if it came right here, for instance. A secant line is a line that intersects a circle at 2 points. So in this line right here, it's intersecting the circle there and there, so in both of those places. Now the other formulas that we've discussed, this chart pretty much sums it up. We have where the angle's vertex is, that's the little pointy part. So if you're not sure what a vertex is as of yet, basically it's this little area right here, the pointy part of the angle. Not very scientific, but I think that sums it up. So if that vertex is at the center of the circle, then we know the arc and the angle are the same thing. Now if it's on the circle, we know that the angle itself is half of whatever the arc is. Or the reverse, the arc would be twice as big as the angle. These are the two situations that are a little bit new to us, when it crisscrosses inside a circle and when the vertex is outside of a circle. So this chart just tells you if it crisscrosses inside the circle, like this example down here, that's a situation. Then what you end up having is you basically take the average of the arcs, you add the two up, and then you divide by 2. So if it crisscrosses and it's not crisscrossing right at the center, then you're going to take this arc plus this arc and divide it by 2. The reverse is true if they crisscross outside of the circle. So if you have a situation that looks like this, and you might have it out here like that, in that case, you're going to take the difference of the two arcs, that arc and that arc, and then you'll divide by 2. So inside the circle, we broke it up with the picture down here. Inside the circle, the measure of angle 1 equals 1/2 the arc degrees for x, which is right here, plus the arc degrees for y, which is right here. You take half of that or divide by 2, however you want to look at it, and that's going to give you this angle 1, which is also this angle because they're vertical angles. Now if it crisscrosses outside of the circle, so in this case you are going, and you have 3 situations in which the vertex is outside of the circle. Okay, you can have 2 secant lines coming together outside the circle. You could have a tangent line and a secant line coming together outside of the circle, or you could have 2 tangent lines coming together outside of the circle. All those mean the same thing. The vertex is outside of the circle. So they all use the same formula. You take the x arc minus the y arc, the bigger arc minus the smaller arc, or you're going to end up with a negative answer. So the big arc minus the small arc, big arc minus the small arc, and you are cutting that difference in half. So let's do some examples. So really you're only learning 2 more formulas, and they're not so bad. They're pretty basic if you can just remember the pictures. So in this case you ask yourself, where is the vertex? Is it in the center? Is it on the circle, inside, or outside? Those are the 4 situations. That's the first question you need to ask yourself. Once you determine what the answer is, then you know which formula to use. In this case, the vertex is outside the circle, so that's like a situation up here. So we're going to have to take the difference of the 2 arcs. So we're going to take the 92 degrees and the 268 degrees, subtract the 2, bigger minus smaller, and cut that difference in half. So 1/2, 268, because that's bigger, minus the 92, and you put that in the calculator, and you get 88 degrees. So now I know that x is 88 degrees. Simple enough. Let's look at B's example. Where does the vertex, where do the lines cross? They cross inside, and it's not at the center, so I know I need to add these two and divide by 2, which is basically taking the average. So 1/2, 112 plus 94. Put it in the calculator, and the measure of angle x is equal to 76 degrees. Okay, let's look at Theorem 1212. Now, we dealt with angles just a minute. These are line segments. So if you have two segments that are fully inside of a circle, like this situation, basically you have this whole line, the pink line, and this whole line, the blue line. You're going to take their parts and multiply them together. So each part of the pink line, multiply them together, that should equal each part of the blue line multiplied together. Those are if they crisscross inside. Now, if they connect outside, the segments have a little bit of a different situation. You have to add the two pieces together, and you multiply by the outside piece. So inside times inside plus outside times by the outside piece. Add the two, or basically, because it's not always going to be broken up, you're taking the entire thing. A lot of times you're going to have to add this. Sometimes you won't, but you're going to want to take this entire line and then multiply it by the outside piece. So if they give you like 3 and 2, then you're going to add them together, 5 times by the outside piece. They might give you x and 3. Then you would have to do 3 plus x times by the 3, which was the outside piece. That situation. And then same goes for the other side. So here, the whole line, z plus y, whatever that happens to be, times whatever segment is on the outside. And these two are actually the same thing, but because they figured students would get confused because it's only an outside piece in this situation, think about it. If you applied this number 2 to this number 3 situation, this is what you would end up with. There is no inside piece, so the inside plus the outside would be 0 plus t times the outside piece is t, and that equals the same thing, the whole thing, z plus y, times the outside y, so that's the same, but what do you end up with here? You end up with t squared. So basically this isn't like a new formula, but since there is no inside piece, the whole thing is 0 plus the outside piece, so it's just the outside piece times the outside piece, which is t squared in this case. So that is the situation. So you're going to find out where do the line segments cross, because there's no angles in these pictures, so make sure you can differentiate between these 3 situations. Alright, so in this case, so an advertising agency wants a frontal photo of a flying saucer ride at an amusement park. The photographer stands at the vertex of the angle formed by the tangents to the flying saucer. What is the measure of the arc that will be in the photograph? So you are dealing with angles, and the vertex is on the outside, so that differentiates between the sets of formulas that you're going to use. So this is the difference of the two arcs cut in half. Well, we don't have the second arc, so you're going to have to do 360 minus the arc that you do have. So here, 360 minus 72, and then that's going to give you what that XAY arc is, and then you end up getting 360 minus x, because we don't know what this is. So this is very confusing, as in this right here is 72, not the arc. Okay, so let's get that situation straight. When you guys are doing this, you have two variables. All right, so when you're looking at this and you're not giving any of the arcs, then you're going to have to use kind of like code. So you'll call one thing X, and then, for instance, we did the X as this portion, and then you're going to name the other portion in terms of X. So we know that the whole circle is 360. So if we go from X to Y, from X, A, Y, because I don't want you to go the other direction. So when we go this direction, we know that it is 360 minus whatever this little small arc is. So when we name that, we want to name it 360 minus X. So that's what arc A, X, A, Y is. So measure of arc X, A, Y is 360 minus X. So when you're solving this, you're going to figure out what formulas to use. Now our vertex is outside of the circle, so that means we're going to have to take the difference of the big arc and the small arc. So that means take the big arc minus the small arc and divide by 2. So the big arc is, or the formula, I'll write the formula, 1/2 the big arc minus the small arc. So if we fill in the big and the small, I end up with 1/2. The big arc is 360 minus X minus the small arc, which is X. Now I have to simplify that because it's a bit messy. This is 1/2 360 minus 2x, and when you're doing this, you're going to want to say, okay, well, I have this simplified. Well, what does that equal? That equals this outside angle here, the 72. That's what the 72. So this outside angle is equal to 1/2 the difference of the big arc and the small arc. So I'm going to go ahead and say this equals the 72. So when I do that, I can simplify this. Now you can distribute the 1/2 to the 360 if you want, and then to the 2x. That's perfectly fine. Or you can multiply both sides by 2. It's totally up to you, whatever you want to do. To deal with smaller numbers, I think I'll go ahead and distribute the 1/2. But if these weren't even numbers, then you wouldn't want to do that. But in this case, it would work out just fine. So this would be 180, because 1/2 of 360, minus x, because 1/2 of 2x is 1x, equals 72. So from here, depending on what you want to do, you can subtract 180 and have two negative numbers, or you can move the x and then move the 72. I'm just going to keep it to one step. So I'm going to go ahead and subtract the 180 to both sides. So I end up with negative x, don't forget to bring that negative with it, equals -8. And then because both are I'm sorry, not -8, -108 rather. Let me redo that. -108. Since both of these are negative, we can just wipe out that negative sign, like dividing by -1. So now I know that x is 108. So that's the arc. So that is the arc that will be in the photograph. That's the measure of the arc that would be in the photograph. So let's go to the next one. So in example 3 here, you determine where is the vertex. Well, the vertex is inside the circle and it's not at the center. So we're going to look at, now we don't have the angles this time, we have the segment lengths. So we got to refer to the theorem 1212. So on this one, we said we take the two pieces, so in this case it would be x and 5, and you multiply those together, so 5 times x, and that should equal the other two pieces multiplied, 3 and 7. 3 times 7. So you get 5x equals 21, divide by 5, and you end up with a decimal, which is correct, 4.2. For part B, the vertex is outside the circle. So what you want to do is get that formula. Now this is the third one. Remember there was 1, 2, and 3. So what you end up doing is saying the whole thing, the long one, I'll say this one right here, the whole line is y plus 8 times the extra outside piece, 8. That should equal the whole thing times the outside piece, which is 15 times 15, or 15 squared. So when you simplify that, we end up getting, you can distribute the 8, so you end up with 8 times y and 8 times 8, so 8y plus 64 equals 225. We got to subtract the 64 from both sides. So you end up with 8y equals 161, and then divide both sides by that 8. So you end up getting a y value of 20.125. So y equals 20.125. And then number 4 is tricky. When you're doing this last example here, well, it's not the last example, second to last example. A tram travels from point A to point B along the arc of a circle with a radius of 125 feet. So basically when you're looking at this, if you completed this circle, I guess, try and give you guys, if you, oh, that's a horrible completion, but if you were to, this right here, the radius is 125, okay? So this missing piece, I guess, right here, that missing chunk would also be part of the radius. So if you went from here all the way down, and this little bit is 50, to get to the 125, this would have to be 75, because 125 minus 50 gives you 75. So that's the missing piece that we're looking for, and you know those two are y's. What I'm doing is creating a situation for that 1, 2, and 3 formula from above with the line segments. So now we have crisscrossing inside the circle, so we know that it's a similar situation to example number 3 that we did, which would be from theorem 1212, the formula number 1. So we're going to take the two pieces, and those two pieces should equal the other two pieces. So this whole thing, this side, or that line, is y times y equals, where they crisscross, 50, so this chunk right here, times the other section, which is this right here, 75 plus 25, which is 200. And I'll just put a little note here. That's 200 right there, because I just added them together. 75 plus 125. So now we have that situation, and we can just simplify this. Y squared equals, we end up getting 10,000. And then square root, and you end up with a y value of 100. And they want to know, find the shortest distance from point A to point B. So from A all the way over to point B is 2 y's. So if one y is 100, then the other y is also 100. So the shortest distance, AB, is 200. That's the answer they want. And last but not least, example 5. So given the tangent and the two secants to the circle, find the value of each variable to the nearest tenth. So when we're looking at this, we have angle A here. Now you don't have to start with A, but I'm going to. A right here is the difference of the 60-degree arc and the 175-degree arc cut in half. So measure of angle A equals 1/2 175 minus 60. Simplify that, and we end up getting 57.5, I believe. So measure of angle A is 1/2 of 115. So you get 57.5. So that's what angle A is. Now for the X portion, these are the outside pieces. So we have the outside and the inside, the outside and the inside if you want to look at it that way. So we're looking at these pieces right here. So if you do that, you end up with the whole line. I'll do the 9 and 12. So 9 plus 12 is 21 times the outside piece 9 equals the whole line here. That's 8 plus x times the outside piece 8, and I'll simplify that. So 9 times 21 is 189. Distribute the 8, so you get 64. Oh, how about 64 plus 8x. Subtract the 64 from both sides, and then we would divide by the 8. So 125 equals 8x, divide by 8, and you end up with 15.625 for our x. And last but not least, we can do either the 9, I'll do the 9 and 12 and then the y's. So a similar situation, we have the same thing here, 9 times 21, the whole line is 21, equals, since we just have a tangent line there, remember it's just y squared. The whole thing times the outside piece is y times y. So we get 189 equals y squared, square root both sides, and you end up with approximately 13.75. And that completes this set of notes. I had to pause a bunch of times, so I don't know how it turned out, so hopefully it turned out okay.